Now my dear students, this is the question number 12. Two possible stereostructures of CH3, CHOH, COOH which are optically active are called. My dear students, because here chiral carbon atom is present and due to chiral carbon atom, those compounds which are optically active is called enantiomers. So you can see that optical isomers compounds are also called enantiomers. Here my dear students, so you can go the question 12, B option is the correct answer. Now we can see in an SN1 reaction on chiral centers there is an inversion more than retention leading to partial racemizations or 100% retention, 100% inversion, 100% racemization. Now my dear students, what is the concept behind this question? Concept is this: in SN1 reaction, when you can see the CH3 and Br. My dear students, in this compound ethoxide C2H5O, it is a strong nucleophile and this strong nucleophile attack on in this type of halide ions. When this halide ion is broken down, then you can get the bromide anions as well as carbocation. This is the anions and this is the carbocation. Now my dear students, here when this C2H5O minus ions are attack on this is the attack on this carbocations first of all, because this carbocation is stable. So this carbocation is stable and then C2H5O minus ion is attack, and when this is attack, inversion is take place here, because this CH3 and CH3 is reverse inside in the space, it is called inversion product. You can get the OC2H5, you can get in this type of product. OC2H5 and here carbon, here you can get this CH3 1, 2 and this is the 3. So my dear friends, this compound or this is called inversion. You can get this type of product. CH3 is present in space in this side, left hand side, and it is coming to the right hand side. So my dear students, this is called inversion. Because this tertiary carbocation is more stable, it is present in the solution. So in SN1 reaction, here inversion more than the retention, here inversion is more and leading to the partial racemization. So you can go the answer A, 13A. Now my dear students, we can go the question number 14, which is asked in 2014. Which of the following compounds will undergo racemization when solution of QH hydrolysis? Here my dear students, racemization is present those compound in which chiral carbon atom present or chiral carbon atom is present. Here my dear students, you can see only one compound, fourth compound in which chiral carbon atom is present. What is the chiral carbon atom? Is that carbon atom in which 4 different groups are present. We take the example because here you can see no one another than this fourth example in which chiral carbon atom is present. Here you can see in this carbon atom 2 alkyl groups are same. One is CH3 and second is CH3. So 2 alkyl groups are same on this carbon atom. So my dear students, it is not a chiral carbon atom. When you can see this carbon atom, it is also not a chiral carbon atom, because 2 hydrogen atoms are attached with this carbon atom. Now when we can see this carbon atom, in this carbon atom 2 hydrogen atoms are same, so it is not a chiral carbon atom. In this way my dear students, when you take the answer, then answer is not given in these options, because only fourth option only in fourth option compound give optical isomerism or racemization. Optical isomerism, or it is also called racemization. It is also called as racemization. So, my dear students, you can give only fourth option. It is a correct answer, and so these options are given. Only fourth is not given. So, you can here write fourth. Now, when we can see the question number 15, which are asked in NEET 2013 Karnataka state. Here, my dear students, you can see the structure, and in this structure, here the structures are identical, or pair of conformers, or a pair of geometrical isomers, or a pair of optical isomers. Here we can see the optical isomers are shown by those compounds in which different groups are attached. Here geometrical isomerism are shown by in which double bond is present. So, this and this not answer. These are not identical, because here you can see some groups are different. Here Br is present in lower side, and you can see the Br is present in upper side. That is why this form is called, my dear student, it's called a staggered form. And you can see here in this haloalkanes, and here Br is present in this side and Br is present in behind this side. So, my dear students, it is called eclipsed form, and eclipsed and staggered forms are present in haloalkanes, and these are called conformers. So, my dear students, question number 15 answer is B. Question number 15 you can get the answer B. Now, we can go to the question number 16. Which of the following acid does not exhibit optical isomerism? My dear students, those compound, what is the concept? Concept is this: those compounds in which chiral carbonatum is absent do not show optical isomerism. Do not show optical isomerism. Here, my dear students, when we see the name of the compound, first of all you write the structure. After malic, malic is a C double bond C, H, H, C double OH and C double H. It means double bond is present. So, it show geometrical isomerism, but not it show optical isomerism. Here B, you can see the alpha amino acids means NH2, CH2 and COOH. Here, my dear friends, when this alpha means this hydrogen atom is replaced by another group, so you can get R, and when you can get R, then this compound show optical isomerism, because in this carbon atom different groups are present, NH2, R, H and COOH. So, my dear friends, this is show the optical isomerism. Now, we can see the lactic acid. Lactic acid is the CH3, CHOH and COOH compound. Here in this compound, this carbon atom is asymmetric, and here you can show the tartaric acid, that is CHOH, COOH and CHOH and COOH. So, this compound, both carbon atom or chiral carbon atom show optical isomerism. So, only one compound, malic acid, not show optical isomerism. Answer is A. Here, my dear students, we can go to the question number 17. Consider the reaction CH3 whole twice CH, CH2Br, here C2H5OH, and you can get the CH3 whole twice CH, CH2O, C2H5 plus HBr. And second reaction, here you can see the reaction, this Br is replaced, and here this C2H5O means ethoxide group is attached in place of Br. Here, my dear students, here you can see Br is replaced, and this C2H5O minus is attached in place of this Br. So, you can see here, my dear students, here no inversion is take place. So, these are called SN2 type reactions. So, my dear students, these are called SN2 type reaction because in SN2 type reaction carbocation is not formed. So, you can see your concept. Number 1, in SN2 reaction, carbocation is not formed. So, my dear students, here carbocation is not formed. Number 2, transition element, transition state is formed in SN2 reaction. So, my dear students, here transition state is formed. So, you can go the option C. C is the correct answer. Question number 17. Now, my dear students, we go the question number 18. Which of the following compounds undergoes nucleophilic substitution reaction most easily? My dear students, those compounds concept is this. Those molecules are groups. So, you can see those groups which are attached with benzene ring, attracts electrons. So, increase the nucleophilic substitution reaction. Here, my dear students, we can see the here NO2 group here attracts lone pair of electron. It is called electron withdrawing group. So, it's increase the reactivity of nucleophilic substitution, and vice versa. Those groups which gives the or repel the electrons decrease the reactivity of nucleophilic substitution. So, it decrease the and it's increase the nucleophilic substitution reaction reactivity. Here, my dear students, in oxygen lone pair electrons are present on oxygen. So, this lone pair electrons give this electron to this carbon atom. So, it's decrease the reactivity of nucleophilic substitution, and here chlorine atom is show the nucleophilic substitution reaction reactivity. So, you can go the answer A, my dear students. Question number 18, answer is that is A. Now, my dear students, we can go, this question is asked in NEET 2011 and this is the concept of this question. Now, we can go to the question number 19. Which one is most reactive towards SN1 reaction? Earlier, I give you concept SN1 reaction given by carbocations. So, tertiary carbocations is more stable. So, you can see the reactivity of stability of carbocation. First is, my dear friends, CH2 plus benzyl carbocation, and second is CH2 double bond CH, CH2 plus allyl carbocation, then tertiary carbocation, then secondary carbocation, and then primary carbocation. In this way, you can see this is the reactivity. Here, my dear friends, when benzyl carbocation is more active, then you can see in which compound in which these carbocations are formed. You can see here when this Br is first of A option, you can draw the structure formula. This carbon atom get the CH5, so you can see this carbon atom this carbon atom attach this benzene ring. Here these two benzene rings are attached with this carbon atom. Here hydrogen atom attached here, you can get the Br group. So when this broken down this carbon and bromine bond, you can get the positive charge present on this carbon atom. Here my dear students, when you see the B option, you see this carbon atom, all groups are attached. Here this carbon atom, all groups are attached. Here only this carbon atom Br is attached. Now in B option we can see this is a Br. Here you can see this benzene group 1. Here you can see this CH3 group is attached here. When this Br is go down the solution, then positive charge present on this carbon atom. Here CH5 CH3 group is present. Here you can say this is benzene group is present. This is the difference between A and B. Now we can go to the C. Here C, my dear students, this is the carbon atom. Here these are the Br group is attached. Here one benzene group. Here second benzene group is attached. And here you can get CH3 group. In place of hydrogen, here CH3 group is attached. When this Br minus ions go in the solution, then carbocation is formed. Now my dear students, you can see the tertiary carbocation is more stable, then secondary, then primary. Here you can see the two benzene group and one methyl group is present. Here you can see the one benzene, one methyl, here two benzene and two benzene only group is present in carbocation. So my dear students, this two phenyl and one methyl group is present with this carbocation. So this carbocation is more stable due to this R effect and this I effect. And this carbocation show this I effect means plus I effect, as well as you can see here hyperconjugation is also present. So my dear students, when you can go to this question, this C is the correct answer, this is the correct answer, this carbocation is more stable. My dear students, in question number 20, the correct order of increasing reactivity, it is the same. You can broken this halide ion and get the carbocations. You can broken this halide ions and get the carbocations and see these carbocations. You see the tertiary carbocation is more stable because here this carbocation 3 alkyl groups are present. So this is the called tertiary carbocation, and tertiary carbocation is more stable than secondary carbocation, which is obtained by this fourth. You can get the secondary carbocation, here you can get the tertiary carbocation. So my dear students, when this is more stable means order of increasing reactivity is more for the nucleophile. So my dear students, when we can see here third is more active, you can go the option A, because only A option third is most active. Here B option fourth most active, here D option fourth most active, but here only A option in which you can get the third is most active, then you can get the fourth, then 2 and 1. Here my dear students, in 2 is more active than this 1. Why? Because EDG group, 2 electron withdrawing group, EWG group, 2 electron withdrawing group is present. It is called EWG group. My dear students, it is also called EWG group. 2 electron withdrawing group is attached with this benzene ring. So my dear students, it is a second is more active than 1. So in question number 20, which is asked in NEET 2010, answer is A. My dear students, in question number 20, the correct order of increasing reactivity, it is the same. You can broken this halide ion and get the carbocations. You can broken this halide ions and get the carbocations and see these carbocations. You see the tertiary carbocation is more stable because here this carbocation, 3 alkyl groups are present. So, this is the called tertiary carbocation, and tertiary carbocation is more stable than secondary carbocation, which is obtained by this fourth. You can get the secondary carbocation, here you can get the tertiary carbocation. So, my dear students, when this is more stable means order of increasing reactivity is more for the nucleophile. So, my dear students, when we can see here third is more active, you can go the option A, because only A option third is most active. Here B option fourth most active, here D option fourth most active, but here only A option in which you can get the third is most active, then you can get the fourth, then 2 and 1. Here my dear students, in 2 is more active than this 1. Why? Because EDG group, 2 electron withdrawing group, EWG group, 2 electron withdrawing group is present. It is called EWG group. My dear students, it is also called EWG group. 2 electron withdrawing group is attached with this benzene. So, my dear students, it is a second is more active than 1. So, in question number 20, which is asked in NEET 2010, answer is A. Now, my dear students, we can go to the question number 21. Here we can see in the following reactions, CH5CH2Br, number 1 is magnesium in presence of ether. What product is formed? Here we can see the reaction. Any alkyl halide when reacts with magnesium and ether to form Grignard agent. It's a number 1 reaction, number 1 concept, reaction and concept. My dear students, any alkyl halide reacts with magnesium and ether to form Grignard agent. Here, my dear students, this alkyl halide CH5CH2Br. Here you can see the reaction. In this reaction, C6H5CH2Br reacts with magnesium and ether to form, my dear students, 6H5CH2MgBr. And this H5CH2MgBr detergent, when hydrolyzed by water, you get H and OH ions from water. My dear students, this compound is broken, this Grignard agent is formed and it is broken in this way. Negative charges develop on this CH2 group and positive charge develop on this magnesium. So, my dear students, this H plus ions attached with this CH2 minus. So, you can get the product and it is CH5CH3 plus byproduct is Mg, Br and OH. So, my dear students, here you can go the answer C is the correct answer. This is toluene CH5CH3. Now, my dear students, we can go to the question number 22, which is asked in 2009. Which of the following reaction is an example of nucleophilic substitution reactions? My dear students, nucleophile is those compounds in which electrons are present and it is substituted. Here you can get the nucleophile, Na is not nucleophile, hydrogen not, these are act as a reducing agent. So, sodium is act as a reducing agent, hydrogen is act as a reducing agent, magnesium is act as a reducing agent and here KOH. Here KOH you can get the nucleophile OH minus ions. My dear students, this OH minus ions is act as a nucleophile, so it attacks on this Rx. You can get the reaction, my dear students. This is Rx, this is OH minus ions, which is act as a nucleophile, is attack on this R group. My dear students, here you can see the Rx. Here this halogen is more electronegative than carbon. That's a partially negative charge present on halogen, and here, my dear friends, partially positive charge present on this alkyl group. So this OH minus ions is attack on this R plus and form a transition state. My dear friend, this is called transition state. When this transition state TS is broken down because this bond is stronger and stronger, and this bond is weaker. So X minus ion go in the solution and you can get the ROH. So my dear friends, when you can get this ROH product, this reaction is called SN2 type reaction, because in this reaction two molecules, 1 and 1, two molecules is take part in the reaction, so it is called bimolecular. This is nucleophile, this nucleophile is attack on this, so it is called bimolecular nucleophilic and it is called substitution. So this reaction is called nucleophilic substitution reaction. So my dear friends, you can go answer D. Now my dear friends, we can go the question number 23. How many stereoisomers does this molecule have? Here my dear students, you can see the CH3, CH, double bond CH, CH2, CHBr, CH3. My dear students, when you can draw the structure, this CH, double bond C, so you can draw this H here, and you can get this H. In this bond is attached with this CH2, CH, here Br and CH3. Now this is the structure formula of our compounds. My dear student, this structure formula show two information. Number one information is that double bond is present between carbon and carbon. We get two information. One information is that double bond is present between carbon and carbon atom. So it gives your geometrical isomerism, and you can get two geometrical isomers. One is cis and another is transform. When this H group is present on same side, it is called cis, and when this H group is present opposite, that is called transform. Another information you can get, my dear students, that is this carbon atom is a asymmetrical carbon atom, because here you can get the different alkyl groups are attached with this carbon atom. My dear students, when different alkyl groups are attached with this carbon atom, so it is optical activity show, and here only one carbon atom is present. So total number of optical isomers may be calculated by the formula that equal to 2 ki power n. Here n is the asymmetrical carbon atom, that is 2 ki power 1, that is why you can get the 2. So geometrical isomers is 2 and optical isomers is 2. So in this question which is asked in NEET 2008, here he want total number of stereoisomers, and you can get 2 plus 2, that equal to 4. So, my dear students, in this question number 23, you can go option C, that is 4. Now, my dear students, we can go to question number 24th. In a SN2 substitution reactions of the type RBr plus Cl minus DMF in presence of, this is polar aprotic solvent, dimethyl formamide, RCl to give Br minus. Here you can see this is the SN2 type reaction, okay, and which one of the following has the highest relative rate? My dear students, for concept is this. For SN2 reaction, primary alkyl halide is more reactive than secondary alkyl halide, and secondary alkyl halide is more active than, this is tertiary alkyl halide. Now, my dear students, we can see here this primary alkyl halide is this one. So, it is more reactive for SN2 reaction. Here this is the primary alkyl halide. Here primary carbocation is also present. Here, my dear students, this is also primary alkyl halide, but you can see here this bulky group is present here. So, it creates us hyperconjugation and other effects. So, my dear students, second point is that transition state is present, must be present in SN2. Here, my dear students, transition state is less because molecule is bigger, transition state is less. Here it form transition state is less. So, transition state is less form in this compound. Primary alkyl halide is present in all compound, but here second point is that transition state is also present, and here this is the hindrance is present in this compound. So, my dear students, highest relative rate is only answer is B. So, question number 24th, you get the answer B. Now, my dear students, we can go to the question number 25. If there is no rotation of plane polarized light by a compound in a specific solvent thought to be chiral, it may mean that, my dear students, it is a answer A, because meso compound do not show the optical activity. So, my dear students, answer is A. In meso compound, no rotation of plane polarized light you can get, because in meso compound you can see when one part rotate light clockwise direction plus half, and second part is rotate right left hand side, that is minus half. So, plus half and minus half are cancelled with each other. If you get this tartaric acid COH and second one is COOH and OH. If, my dear students, this is the tartaric acid, and in this tartaric acid, and my dear students, in this tartaric acid you can see this carbon atom rotate light in this direction plus half, and this carbon atom rotate light in this direction minus half. It means both are cancelled with each other. So, my dear students, optical activity is cancelled with each other. So, this compound, this type of compounds are called meso compound. Due to this formation of this meso compound, my dear students, you can go to the answer A, because meso compounds are optically inactive. Now, we can discuss the question number 26. Here, my dear students, you can discuss CH3, CHCl, CH2, CH3 has chiral center. Yes, this is the chiral center here. Which one of the following represents is R configuration? What is the concept of R configuration? My dear students, when we can give the priority, we can give the priority, give first priority of group. It is a first, and second one is that if direction is clockwise direction, then it is a R. We can give the priority, and hydrogen is always present in below. Below hydrogen is always present. Here you can see this hydrogen B and C, B and D, hydrogen is present in below. Now, my dear students, when we can see this hydrogen atom, this is priority 1, because atomic number is higher. its group priority 2 because atomic number is 1, then this, and priority 3 and 4. Here my dear students, when we go 1, 2, 3, then this is the clockwise direction. That is why it is called R, R for right. So, this configuration is called R configuration. So, my dear students, you can go the answer B. Now, my dear students, we can see the question number 27. Which of the following is not chiral? 2-hydroxypropanoic acid, you can first of all, you can write the structure of this compound. Propanoic 1, 2, 3. Here COH group is present, my dear students. 1, and you can get the OH group on second carbon atom. Here this is the CH3 group. So, you can get the, here you can get the 2-hydroxypropanoic acid. Here you can get different groups are present in this compound. So, this is the chiral carbon atom. So, this is correct answer, but here he want the not chiral. This is chiral. So, you can write the B option, and B option is, my dear students, here 4 carbon atoms are present, 1, 2, 3 and 4. Here OH, because you can see here 2 all, that is why 2 all is present on second carbon atom OH. Here H, CH3, here this CH2 and CH3. This is ethyl group, hydrogen, methyl group and OH group. So, it is also a chiral, but he want not chiral, it is a chiral. So, you can see here draw the diagram of third C option. Now, 2,3-dibromopentane. First of all, you can draw the pentane 1, 2, 3, 4 and 5. 1, 2, 3, 4, 5. Here 2 Br present. Here 3 Br present. Here this is CH2, CH3. Here this is the CH3. Here, my dear students, 2,3-dibromopentane structure. And in this structure, you can get that this is chiral because this is different group, this is different group and this is different group. Now, we can see this is the answer because only one option is there, and you can write the structure of this pentane 1, 2, 3, 4, 5. Br group is present. Here H. Here you can get the same groups, that is ethyl groups. So, my dear student, this is the answer because same groups are present. So, it is not chiral. My dear student, this question is asked in 2006 NEET exams, and you can see in these questions 3-bromopentane is formed, and in 3-bromopentane chiral is not present because same group ethyl groups are present. My dear students, which of the following undergoes nucleophilic substitution exclusive by SN1 mechanism? Here concept is that which compound carbocation is stable gives SN1 reaction. Here you can see here this benzyl chloride. When you form this benzyl chloride, and benzyl chloride is dissociated, it gives us a stable benzyl carbocation, stable, and is the most stable. So, it is the most stable carbocation and it is a benzyl carbocation. So, my dear students, it goes to the SN1 reaction. So, which of the following undergoes nucleophilic substitution reaction exclusive by SN1? It is answer is D, because it is a most stable, because its form most stable carbocation. This is the answer. Chlorobenzene is not form isopropyl chloride. When you can see the isopropyl chloride, it is formed secondary carbocation. Ethyl chloride is formed primary carbocation. So, SN1 given by the stable carbocation and which is given by this benzyl. Benzyl carbocation, my dear students, it is stable then. CH2 double bond CH, CH2 allyl carbocation, it is stable than tertiary carbocation, it is stable than secondary carbocation, it is stable than primary carbocation. It is the most stable carbocation, so it forms thus as it gives us an one reaction. Now we can go to the question number 29. Here, my dear student, chirality of the compound, and this question asked it is R or S configuration. My dear students, here this is number 1, here this is number 1 and this is number 2 because chlorine is present, and here this is number 3. Now we can go the 1, 2, 3, so it is called R. So we can go the answer A. Now my dear students, we can see the question number 30. Which of the following is least active in a nucleophilic substitution reactions? It's a very simple question because those carbocations are most stable are more reactive. Here you can see this carbocation is a more reactive, so most reactive because it's most stable. Here this is when broken this compound you can get the primary carbocation, and here you can also get the primary carbocation which is present in resonating form. Why? You can see here. When, my dear students, positive charge single bond double bond is present, it means here resonance is take place, and when resonance is take place, this carbocation is more stable due to this resonance. So, my dear students, you can see here answer is your B. It is a least reactive because this CHCl in B option, CH2 double bond, CH and Cl. My dear student, when this Cl group is go to the solution, it forms CH2 double bond, CH plus charge. Because this carbocation is least stable, this carbocation is least stable, so it is this molecule is not formed this least stable carbocation. So this molecule is not react. This molecule is not want to go this chloride ion in the solution. So my dear students, this CH2 double bond CH is not formed because it is the least stable. So it is get this Cl minus ions and convert in this further. This is convert in this further CH2 double bond CHCl. Get the plus Cl minus ions and convert in this compound. This compound is called, my dear students, vinyl chloride. So you can say that this carbocation, vinylic carbocation, it is also called, name of this compound is vinylic carbocation. This vinylic carbocation accept this chloride ions and convert in this vinyl chloride quickly because it is a least stable. So this reaction for this nucleophilic substitution reaction means replace of this chloride ion is this vinyl chloride is not bound, so it is a least reactive. Now my dear students, we can go to the question number 31. Here, my dear students, we can see the question which of the following pairs of compounds are enantiomers. Here you can see these pairs, here OH, here this OH, second pair is this OH, here OH is here and OH is here. Means here this compound is so mirror image with each other. My dear students, concept is that concept. Those pairs of compounds show mirror image with each other give optical isomerism. Give optical isomerism. Here, but both are not superimposable with each other. But both are not superimposable with each other. So, here my dear students, answer is A, because both are from mirror images, and when you can put second molecules and place on first molecule, those are not superimposable with each other. My dear students, superimposable means this type of molecules are formed, these are the fishes, and this type of when molecules are formed, those are called superimposable molecules. These are not superimposable with each other, because superimposable both molecules, these molecules are superimposable with each other. So, first and second, this is the first compound, first molecule, and this is the second molecules, both are not superimposable with each other. So, answer is A, question number 31. Now my dear students, we can go to the question number 32, reactivity order of halides for dehydrohalogenation. Here my dear students, we can see the halogens, fluorine, chlorine, bromine and iodine. We can see when this fluorine is most reactive, then chlorine, then bromine and iodine. And you can see here, my dear students, atomic size is increases when we move top to bottom in a group in 17th group. So, my dear students, this iodine when formed Ri and this fluorine when formed Rf. You can see here alkyl group and iodine is bigger in size. Here this alkyl group and fluorine both are small in size. So, here bonding is strong and here bonding is bigger because distance is large. So, my dear friends, when this is reacts with dehydrohalogenation, means halogen is removed from this alkyl halide, it is easily because bond length is maximum %. Here my dear students, we can see bond length is minimum. So, my dear students, here reactivity increases. So, you can go the question number 32, you can go this Ri, Rbr and Rf. Here bigger size, smaller size, then or smaller size and small size. So, my dear student, this is the answer. Now, we can go the question number 33. CH3, CH2, Cl, NaCN acts. Here, my dear students, when this Cl is replaced by this NaCN, you can get this CH3, CH2, Cn. When this Cn cyanide group is reduced by this nickel hydrogen, you can get the amines. Then Y is amines and Y compound is formed, that is CH3, CH2, this CH2 and NH2 amines. This is a Y compound. When this Y compound is reacts with acetic anhydride, what is acetic anhydride? CH3CO, O, CO, CH3. This compound is called acetic anhydride, my dear student. When this compound is dissociated in this way, you can get the plus charge acylium ion and minus acetate ions. And my dear student, this acylium ions attached with this, by the removal of this H plus ions, you can get acetic acid and this CH3, CH2, CH2, NH, CO, CH3 is present. So, you can go the answer A. 33 answer is same. H plus ions is removed and this acetic acid is formed and NH group, this negative charge attached with this positive charge and form acetamide, N-alkyl acetamide or N123 propyl acetamide. You can, it is called N acetamide.